So the first thing I want to look at today is if we have something like this. So if I had 6x squared minus 4x minus 10. What do you immediately notice about this? Hopefully. All divisible by 2 is what I was hoping you would notice. Now, it doesn't actually matter if you don't notice that. You could still factor this with Gary's terrific trick. Combine the 6 and the negative 10, look for factors of 60, whose difference is negative 4. But it's going to be easier if you first factor out the 2. So if we pull out a 2, we'd have this. 2 times 3x squared minus 2x minus 5. And this will just be a little bit easier to factor because we're working with smaller numbers. Right? So this is factoring out the GCF, the greatest common factor. This is something that you've learned in the past, right? We've talked about it. Gary has shown you this a lot, factoring out the GCF, and it still applies. And it just doesn't come up that often, but when it does come up, you want to try to remember to do this. So let's just finish this one. 3 and negative 5 makes negative 15. Factors of negative 15 that are negative 2 apart. Oh, how about 3 and negative 5, right? So kind of a funny example. Then we'll rewrite it as 3x squared minus 5x plus 3x minus 5. Pull out an x here. We have 3x minus 5 plus 3x minus 5. Imaginary 1 in front of that one. And we have 3x minus 5. So just like yesterday. Oh, very good point. We can't forget this too. So I like to try to keep it in each step. In this case, I totally forgot about it, but we just put it out front. It's another factor. You don't have to necessarily. I like to kind of keep it in parentheses so it's separate. But especially when you get to the end, you really don't need the parentheses anymore because everything else is in parentheses. The other thing, I kind of like the parentheses because it really clearly shows we have 3 factors. Now, a really important thing about this, when we go back to finding the zeros, which will be like tomorrow, if this equals 0, then I can actually just get rid of this 2. I divide this side by 2, and then I divide this side by 2, and I just get 0. Because 0 divided by 2 is still 0. So when they're equal to 0, you can actually get rid of that. You can ignore it. But when you're just factoring it, you want to leave the 2 out. Okay. So that's kind of where we are right now. Factoring out the GCF. And let's just do a little bit of practice with just that kind of first step. Like if we had something like this. 9x squared plus 6x plus 21. What would you factor out there? Yeah, 3, right? So we'd factor out a 3. What if you had 17x squared plus 34x plus 17? What can you factor out there? The 17, right? So we'd have 17 times x squared plus 2x plus 1. So look for whatever you think you might be able to factor out. Factor out the GCF. this is gonna be kind of a variation on that, but what about negative a's? What if I have a negative a? So let me get an example of these. Actually, what I want to use that. Let me get an example. All right. So let's say I had something like this. Negative 3x squared plus 14x plus 24. We could try using Gary's terrific trick and factoring this. It would not work. I don't think I don't want to spend the time to like show you that it wouldn't work. Just take my word for it. It won't work. So whenever you see a negative a, you have to factor out a negative 1 from this equation. And that's going to look like this. I'm going to put my negative 1 out front. And then I'm just going to make each term the opposite sign. So the whole point of doing this is now I have a positive a. And then in this example, I now have a negative b and a negative c. Then you factor this. And this is actually an example that we did yesterday. But now I can use Gary's terrific trick just to factor this part of it. So 3 times negative 24 is negative 72. What are factors of negative 72? Whose difference is 14. What would they be? Maybe 18 and 4. Which one of those would be negative?
18.
The 18 because we want a negative 14. Okay, now I'm going to rewrite this. 3x squared minus 18x plus 4x minus 24. Factor that by grouping, so I pull a 3x out of the first two terms, leaving x minus 6. Pull a 4 out of the second two terms, leaving x minus 6. And then pull out the blob, leaving 3x plus 4. And I'm not going to forget my negative like I did before. With the 2, we need a negative out front. And usually you would just write it as negative out front. You could write negative 1 in parentheses, that's totally fine. This is just a little bit simpler. So it's just the negative of x minus 6 times 3x plus 4. Now again, once we start setting these equal to 0 again, what happens to that negative? If I have negative something equals 0, that means that the something also has to equal 0. Right? So in this case, negative x minus 6 times 3x plus 4, if that were to equal 0, we could actually ignore this negative. Because that's still equal to 0. Just multiply both sides by negative 1. Right? And if I multiply by negative 1, I get rid of that negative. 0 times negative 1 is still 0. And so we start to simplify these a little bit more when we set them equal to 0.
Wait, I have a question.
Yeah.
You can just add that equals 0 to like any, just like to the end of the problem.
Yeah, so the whole reason that we're practicing all this factoring is because of the finding the zeros, right? Finding the zeros is the goal of factoring. Right now we're just practicing the factoring. Okay. That's kind of like how you guys started out, right? You started out with no a, or a equals 1, just factoring those. And then you learn, okay, what if this equals 0? How do I find my zeros? And you did like the opposite of x, right? So if you had like x minus 2 times x plus 4 equals 0, then the next step would be, say, x equals 2 or negative 4, right? So this is going to be our next step. That's what we're going to do again tonight. And it's just it's the same thing that you were doing before, it's just a little bit different. A little bit more complicated, because now we have something like 3x instead of just x. Anyway, I diverge. So let's do another one that's negative like that. What if you had something like negative 2x squared plus 11x minus 14. Right, we can't solve that. It's impossible to solve it as it stands because why? Negative a. So we've got to get rid of that. We're going to bring our negative out front. When we do that, we change all the signs in here. So we have now a positive a minus 11x and plus 14. And now we factor that. So factors of 28. We know they're both going to be negative. Make a negative 11. What would those be? Oh. Yeah, negative 7 and negative 4. Perfect. Let's rewrite this. 2x squared. Now what I'm noticing about this one is this negative right here. I know that I'm going to have to keep track of that when I factor by grouping. And so, when I factor these first terms, I'm just going to pull out an x.
What about the negative 1?
Yeah, I don't want to forget this. I usually do forget it until the end, but then hopefully I remember it. Whatever works for you to remember that. So 2x minus 7. Now over here, I'm going to pull out a negative 2. And when I do that, I'm going to remember that it affects both of these signs, because this is in parentheses. So 2x, this now becomes a minus. And I can kind of check that I did it right by looking here and looking here. And those should match. And then I'm going to pull out that 2x minus 7, leaving x minus 2. And then I'm just going to remember, I drew this giant arrow on here so that I would put a negative sign in front of my final answer. All right. Questions about pulling out the negative?
I have a question about how you get 2x minus 7. Like, not in the first one, but the second one.
In the second one? Or is your question about how I got the minus there?
No, just about getting that.
So I look at these two terms, and I look for the greatest common factor between 4 and 14, well, 4x and 14. Right? The greatest common factor is 2. And then I knew that I would need this to be a negative because this one was 2x minus 7. So I pulled out a negative 2 to make this 2x, and then negative 2 times negative 7 equals positive 14. Right? So as you're pulling this out, you're asking yourself, negative 2 times what equals negative 4x? So negative 2 times 2x equals negative 4x. Negative 2 times what equals 14? Well, negative 2 times negative 7 equals 14. So you're kind of asking yourself that. Now, you could have done it this way. You could have said, okay, I got my x times 2x minus 7. You could have said, okay, 2 is the greatest common factor. That leaves negative 2x plus 7. And when you do that, you should realize, wait a second, this is not the same as this. But the only thing that's different is the negative signs. So I'm going to pull out a negative here and switch those two signs. And now they agree. Now they're the same. But I think that's one of the trickiest things about Gary's terrific trick, is remembering this when you have a negative in that second term, really keeping track of how it distributes to both of those terms in parentheses. But you can always check your work. That's the other really nice thing about this. So I can always take this and say, okay, does this actually equal this if I FOIL it? So if I do 2x times x, do I get 2x squared? Yes. If I do, well actually, I'm really checking to see if it equals this, right? If I do 2x times negative 2, I have a negative 4x. And then negative 7 times x is negative 7. And 4 and 7 make negative 11. Okay? And then negative 7 times negative 2, that does equal a positive 13. So I know I just did that without writing anything down. But if I were doing this on a quiz or a test, I would write down the entire foiling process just to check my work. Because there's really no reason you should get any of these wrong on a quiz or a test, because you can check your work so easily. Right? We're just doing FOIL. First, outside, inside, last. And just seeing how that works. All right. Questions? That's all I wanted to cover for today. So ended up taking a little longer than I thought, but that's okay. I guess no one needs to